To the video presentation for the processing of metals by casting. This is going to be the first of two videos on this subject. There's going to be a part one, which focuses on mostly the introduction to casting process, and then also is going to focus on green sand casting. And then part two, we'll talk about other types of casting processes. So let's go ahead and get started. First thing I want you to do is to think about what do all these things have in common. So what do we have? We have some turbine blades that you can find maybe in a gas combustion turbine or a steam turbine that you can find in a power plant. We have an impeller, which is the rotating component you find in a lot of common pumps in industrial facilities. And I know many of you will be able to recognize this. This is a solid engine block. So what are all these things made? How are they all made? Obviously, this presentation is on casting, so they are all made by casting processes. So the basic definition of casting is when you pour or force molten metal into a mold cavity that has a desired shape. You allow that molten metal to cool, and ta-da, you have your product. So let's start with the question, why would you use the casting process to make a particular product? First of all, it's very good for parts with intricate or internal cavities. And here are some examples of parts with intricate or internal cavities, like a valve. So you can't see this because this is just a housing of the valve, but inside the valve, you have some different internal cavities here that would be good for the casting process. You have here different types of housings that have weird internal properties. That's good for casting as well. Also here you have some type of manifold, maybe an exhaust manifold or some type of manifold probably on a car. You see you have a lot of internal cavities here that are smooth and flowing. This would also do well for the casting process and has been cast. So castings result in smooth flowing designs, like I said before, great for internal cavities, and you can put the metal exactly where you want it to be. So how do you get a good cast product? Very important. Let's think about that. First of all, you have to have a way of melting the metal because the metal has to be molten so that it can be poured into a mold. Okay, so you must be able to make it to that correct temperature. That's very important. Then you want to have a mold cavity that has a right shape. Okay, you have to have a way to form that. Next, your molds must be arranged so that when your molten metal is introduced, you can get rid of all this air and gases and things like that. If you have air and gases still trapped in your molten metal as it cools, then it's going to have a lot of defects, voids, things like that, which can weaken and compromise your product. Next, you got to have something to hold the two halves of your mold together. Typically, your mold is in two halves. I've seen it be in three halves before, but usually in two halves. Next, any mold material. So when we're talking about cores, we're talking about the things that you put inside your mold to hold an open cavity, right? Because some of the things that you make with the molding process, they have holes in them in internal cavities. So a core is what you use to hold that shape, to hold that space, right? So you have to be able to have a way to remove those cores. They can't be trapped in the mold after you make your product. All right. Now let's start out with the first thing you need, which is a pattern, okay? Now, a pattern is simply what you use to make your mold, okay? The pattern is usually going to be in the shape of your actual product. Now, what do you need to think about when making a good pattern to create a mold for your casting? Well, there are several things. First of all, you have to be aware of this thing called shrinkage. What is that? So shrinkage is related to thermal expansion and thermal compression, or the opposite of thermal expansion, where it shrinks. Shrinkage is related to that, okay? And so when metal solidifies after being really, really warm or really, really hot, it's going to shrink. So to make those correct dimensions, you have to have what's called a shrinking allowance. That means your pattern has to be a little bit larger than you want your actual product to be, so that when the metal shrinks, it shrinks to the correct size. Another thing you have to think about is called a draft. Okay. So when you put a pattern inside your mold, the pattern shapes the mold, right? But then you have to make sure that you can actually take the pattern out of the mold. Sometimes the pattern will stick. And so a draft is simply a kind of a taper that allows you to remove your pattern from the mold. Another thing you also have to think about is called a machining allowance. So similar to the way that a shrinking allowance works, you have to actually make the pattern bigger to allow for this. Specifically for machining allowances, it's because most of your molds are going to be machined afterwards, okay? And so machining is a removal process, so you have to have additional metal so that you have something to remove during machining. And here you just have an example of some patterns right here. Okay, so these patterns will actually have to be larger than what your actual product is supposed to be, because you need some room to machine some of those surfaces and make them extra smooth. Now let's talk about the sand casting process. Okay, the sand casting process, and we're focusing on what's called green sand casting, which is where you're using sand that's mixed with a little bit of water and some other binding agents. But this sand casting process is good to explain the basic casting process. All right. So what happens during the basic sand casting process? Here we have a diagram explaining that. So here's your final product right here. And then here is what you start off with. It's your patterns, what you use to make your mold. Okay. In the sand casting process, you take parts of your pattern, okay, you put it in the box, and then you force and splish sand down around it. Okay. Oftentimes you'll have more than one piece. Most times you have more than one piece, usually two pieces, but in this case, you actually have three parts, right? But in each case, you add another pattern and then you pack in that sand around that pattern, okay? And then you take away the piece, the parts of the box, take out that pattern, and then what you have is, bam, a cavity, okay? Now, what is this thing right here? This thing is that core I was telling you about before. That's supposed to hold the space. Whoops. That's supposed to hold the space for this cavity right here. All right. That way, it prevents molten metal rather from coming down and filling that space here, because you don't want that space to be filled. And you pour the molten metal in there, and then you wait until it cools down, and then you lift the box apart, and ta-da, you have your casting. So that's the basic process of your sand casting. Okay. So again, sand is compacted around the pattern, and that gives you your shape for your mold. Then everything else goes from there. So why is it good to use sand? Well, sand has some special benefits, and some of those benefits are just kind of easy to use. You can find sand just about anywhere. It's reusable, so you can reuse the sand. There are some sand casting processes where your molds are not reusable. We will talk about that. And then it's very inexpensive. If you go to YouTube and you look up sand casting, you'll find essentially everybody and their mama doing sand casting, because it's easy, it's reusable, and it's inexpensive. All right, so when you're looking at your mold, okay, you want to choose sand that has certain qualities, all right? So these definitions are very important, so pay attention to them. Your first quality is that you want it to have cohesiveness. Now, what that means is that you want your sand to be able to keep its shape after it's being packed together. That's important because that speaks to the quality of your mold. You want your mold to be very strong because it's going to hold the molten metal. If your mold is not strong, it will be falling apart, and then you're not going to have a very good part that solidifies. Refractoriness refers to how well is this sand able to withstand high temperature. So you'll hear that word a lot. Sometimes you'll hear refractoriness, so that's the description of a quality. A lot of other times you hear refractory, so that refers to materials that have that can withstand high temperatures. Next, you want your sand to be permeable. That's described by permeability, the quality of being porous so that gases can escape. Remember before I told you it was very important that gases and be able to escape from your mold, because you don't want those things trapped inside. Once you pour your molten metal, it'll create voids and and weaknesses in your product. And the last one is collapsibility. Collapsibility speaks to the ability of the sand to allow the shrinking metal to move without fracturing. So remember, as your molten metal is being poured and as it cools down, it's going to shrink, okay? And so you don't want this metal as it's shrinking to stick to your mold, and then parts of it going to be shrinking, parts of it going to be sticking. That's going to create cracks in your final product, okay? So collapsibility also allows the cast part to be removed easily from the mold, okay? Sometimes this includes adding additives to help with this, but you don't want to be able to have your mold and then have your solidified cast in there and not be able to move your cast from the mold. Now we're concentrating on green sand molding, which is what the rest of this presentation is going to be about. Now, specifically, what is green sand molding? Well, green refers to the fact that the molding just simply has moisture. Okay, the molding sand rather simply has moisture. It's the most common type of sand molding process. So I mentioned to you before about looking up stuff on YouTube. Most of those people are doing green sand molding. Okay, so the good question is, how is this green sand prepared? Well, usually what happens is you mix sand and clay and water. Of course, that's where the moisture comes from, in a big, huge thing called a molar. That's just a big mixing bowl. All right. Now, there are all different types of recipes for how much sand you have, how much clay you have, how much water you use. People use different amounts, but you want it for the right consistency for you. Okay. And then after that, we want to think about, okay, so what are these molding properties based on? All right. How do we adjust these things? Well, one of the things is you want to choose the correct size for the grain of sand. Now, grains of sand can have different sizes. They can be large, they can be small, depending upon what you want to do. Usually, the smaller the grain of sand, the more accurate your mold and your casting is going to be. All right, you do want to choose the right proportion of clay and water. I mentioned to you before, there's different recipes, but it's very important that you mix that in the right proportion for your for what you need. All right, now let's think of desired properties for the mold. All right, it's important that your mold has the right amount of hardness. You want it to be hard, and the reason why you want it to be hard is because you don't want, when you're pouring in that molten metal, it to be dented or changed. You want to be able to resist being changed in any way because you want to hold on to that shape that it is already in. The next, same thing as we talked about before, we want it to be permeable so that those gases can escape. It's very important so that your product doesn't have these voids and things that can weaken it. And then, of course, you want it to be strong. You want it to stay together and to hold together during the whole entire process. All right, now let's specifically look at the process of green sand molding. Here's a step-by-step diagram, okay? You push the pattern into the sand and make the mold. What do you do next? Metal is heated and you put the two halves of the mold together, and then you pour in that molten metal. What happens next? You take off the mold by separating those two halves of it, and typically what will happen is you'll have your casting and you'll have some other things too that you don't really need because you have to have a passageway for the molten metal to get to the casting. You usually machine those things off and then you have your final product. So here's some other diagrams of what a green sand casting looks like. Now pay attention to some of these details here because you're going to need to know them for your test. For instance, here you have at the top here, it's called a pouring cup. You don't have that pointed out here, but I have another diagram where it will do. And then this right here is going to be called your sprue. That's not pointed out as well, but right here it's called your ingate. And so your molten metal is going to be poured through the pouring cup, go through the sprue, and then this passageway called the ingate, which brings it into the main mold cavity. All right. Now you also, oftentimes you will have a core to hold a little individual cavity inside your casting to hold that space, so that space is still there and the molten metal doesn't fill it up. And then right here you have what's called a riser. And a riser is an extra reservoir to pull from as your metal shrinks. So if you just pour in from this side, your metal will shrink right here, and it won't have enough metal to continue to fill the cavity as the metal inside it shrinks and cools. And so you have an extra reservoir right here. So as your metal shrinks and cools and solidifies, it pulls extra molten metal from here so that there won't be any voids. Let me see if I'm missing anything else. No, let's go to the next diagram. Okay, the next diagram actually points out what the top and bottom halves of your green sand molding are called. The top half is called the cope. The bottom half is called a drag. Okay, and you can see here you have a bit of a different setup. You still have your pouring cup at the top. That's a wider space where you initially pour in your molten metal. And the reason why it's wide like that is because you want to reduce the amount of bubbling and mixing as you pour. You want your pouring to be as smooth as possible, so that way you don't mix in gases that you later have to try and get rid of. Next, the passageway from the pouring cup, which is called the sprues I mentioned before, and then the end gates that will take you to your main cavity. Now, right here, you can see they have a riser. Some risers go all the way to the top and open into the atmosphere and serve as a vent. And some risers don't go all the way up to the top. And it looks like this one is not going all the way up to the top. You can see something different from the diagram that I showed you before, too, is that this riser actually comes in front of the of going to the core, whereas before the riser was afterwards. So you can put it in front or afterwards. Sometimes there are risers before and afterwards. It's however you want to do it. Then here you have, of course, you have your mold cavity. Here they have another core holding that open space because you don't want metal to fill that. Okay. Now what I'm going to do is I'm going to show you a video where somebody is doing a sand casting. Let me make sure this is loud enough for you to hear. Okay, let's go ahead and get started.
In the description. There will also be a link to a video where I show how to cast the aluminium slingshot without the need for woodworking equipment for making the pattern. I got the molding sand off eBay. It is not expensive. To make the mold, one half of the pattern is laid face down into the flask. I apply a bit of talcum powder to prevent the pattern from sticking to the mold. Then
Okay, I'm just going to comment here real quickly. You can see that your pattern is actually set into two, and most of the diagrams I showed you had patterns that could break up. So the first part of the pattern, they put in one part of the mold. Second part of the pattern, they put in the other part of the mold. Remember, these are called cope and drag. Okay, so now we'll keep going.
The flask is completely packed with sand.
The talcum powder is to help to remove the pattern from the mold. You can also see at first when he puts the sand in, he filters the sand because you want the finest sand particles to be closest to your pattern. And then after you have the sand, initial layer of sand around your pattern, after you have an initial layer of sand around your pattern, then you can just pack whatever type of sand in there. It doesn't matter because that sand that you pack in there is just supporting sand. All right, and so now he has created his mold.
Because the pattern had moved slightly.
So another thing is that you saw he said the pattern had moved slightly. This is called mold shift. And it often happens when you're removing the pattern from the mold. Moving it from the mold, you can maybe shift it here, shift it there, and then that actually changes your mold, which is kind of what happened to him right here. So that's one thing that you have to watch out for when you're doing the green sanding casting process. There's a top half of the mold, which is called the cope.
Now the second half of the mold can be made in similar fashion, only that I added a silicone cartridge to form the sprue for pouring in the molten metal.
Here he's just using something, anything to hold the space to form the sprue, which is a column that leads down to the gating system that goes to your main mold cavity. So he's using this to hold the space for the sprue.
Now the mold can be opened and the pattern can be removed.
So here's his sprue here, and now he's going to kind of make a gating system.
Red holes are poked at the high spots of the cavity for the air to escape out of the mold.
What he does, instead of providing that riser, is he goes and pokes vent holes, okay?
To connect the sprue to the cavity.
And those vent holes are used to help those gases escape. Here's creating a gating system to go from your sprue into the main mold cavity.
The mold is closed and now ready for pouring.
Here is using molten aluminum.
In a cold fire and then poured into the mold.
Molten aluminum is commonly used.
The mold won't open and let the aluminum spill.
Molten aluminum is commonly used for hobbyists because it has a relatively low melting temperature, and aluminum is just a really easy metal to work with. You can see also that he's using clamps to hold the two halves together. Right here and right here are his clamps. See here, he has his final shape. You can see that the gating system and the sprue is still attached to it, so that's going to be machined off right here.
I was really surprised how well it turned out. The surface of the casting is really nice, almost acceptable for a slingshot.
Okay, you're not recording.
Yes, I am recording. And another telltale sign of one of those casting products is that you have that parting line. Now, the parting line is essentially the difference between the top half of the casting and then the bottom half of the casting.
The molding sand can be reused several times.
That's one of the benefits of the sand casting process is you can just continue to use the sand over and over and over again. And so it's very, very economical. And now what he's going to do is he's going to finish this off with some grinding to make things smooth. But essentially, that's the whole sand casting, green sand casting process. All right, now let's kind of review on some of the parts of the mold. You have the sprue, that's the column that leads from the pouring cup and then down into the gating system to go to your mold cavity. You have your pouring cup, which is the white part, and that white part encourages better pouring to make it smooth so that you don't mix in gases that later on need to be removed because they might create voids and weaknesses in your part. Your riser, remember, is a reservoir that holds extra molten metal so that it can make sure to feed your molten metal as it cools and as it hardens, and make sure it does not run out of extra molten metal and create cracks and other things like that. Your core, again, is a part to hold a space for a cavity, because oftentimes your castings will have an empty space in there that you don't want the molten metal to go into. All right, now let's look at sand casting in general and think about what are some advantages and disadvantages. Now I'm going to point to either an advantage or a disadvantage, and I want you to kind of think about which one is which. So let's look at the first one. Let's say that almost any metal can be poured into the sand mold. That's going to be an advantage. Okay, one of the great advantages of the sand casting process is that the sand has very high refractory properties. That means it can withstand very high temperatures, which means you can use metals that have very, very high melting temperatures. Next, what about the need for machining in order to finish castings? That's actually going to be a disadvantage because you have to spend more time and spend more money to machine it to closer tolerances and also to machine it to finer finishes. So usually your castings are going to have post-processing that's needed to be done. That's one of the big reasons why you have that machining allowance we talked about before. Next, your tooling costs are low, and then you have the gravity casting process. So gravity casting process just means you use gravity to pull the molten metal into your mold cavity. So you don't have to pay a lot for tooling like you have to do for some other casting processes. It's very inexpensive. That's definitely an advantage. Next, the green sand process cannot cast long, thin sections. That's a pretty obvious one. That's going to be a disadvantage. It's very difficult to have that sand hold very long and very thin parts. So you're not going to be able to use green sand casting for that type of part. Next, there's almost no limit on size, shape, or weight of the part. And part of this is due to its refractory properties, but you can do a green sand casting or this type of sand casting for any size, any shape. There's no limit. Next, your castings really, they need to be defect free. So we're talking about getting those gases caught in there. It's very important that you make sure that that does not happen. All right. We're at the end of this video, but one thing I wanted to show you that I thought was pretty interesting was an interesting way that one guy decided to make aluminum castings. And he did this by pouring molten aluminum into anthills. So what he's actually doing here is he's actually using the anthill as his mold for the casting. So he didn't have to make a pattern. The ants actually made the mold for him, and then he poured molten aluminum into the anthill and then allowed it to solidify. And so now he has his casting. Pretty much what he's doing right now is just kind of cleaning it up. The only thing I think about making these sorts of castings is that you have a big hole in wherever you dug it up from. So I wonder if that was his own property where he has a big hole in this yard. But you can see the next thing that he does, he simply just has to clean it up. So his casting is already made. And there you have it. That is a completed cast. So in our next portion, we're going to talk about other types of casting processes. Thank you, and I will see you later.